Video compression is a very important aspect of how video streaming websites like YouTube, Netflix, and Hulu work. Without it, you wouldn't be able to stream such high-quality, high-frame videos like this one. How did they do that? That's the magic of video compression, which works mostly by minimizing redundancy in the video data. There are two ways to compress a video: spatial compression and temporal compression, also known as intraframe and interframe, respectively. Anyway, I'm going to describe each of these in terms of the JPEG image format and the MPEG video format. Spatial or intraframe compression is applied only to individual video frames. To compress a video frame, you can use the same process that's used to compress a still image like a JPEG. When a JPEG is created, color information of the image is reduced in a process called chroma subsampling, and then the image is split into sections of 8 by 8 pixels called macro blocks. Then all of this fancy stuff is done to these blocks to further reduce the file size. It's easy to see this effect on an image that has been saved with a high amount of compression. All those ugly looking squares are known as compression artifacts. Some images, like this red square, can be compressed more than others, like this complicated photograph, because the red square is very simple with a lot more redundancy. So that's how a JPEG uses spatial compression. Now, for an MPEG, sometimes called a motion JPEG, things are a bit more complicated than just lining up a whole bunch of JPEGs one after the other to be used as video frames. Doing it that way would not allow for interframe or temporal compression. Temporal compression works, again, by reducing redundancy. If you go through a video like this one, frame by frame, you'll notice that many frames are almost completely identical. That's redundancy, which can be easily compressed. For example, for all the parts of this video that don't need to change from one frame to the next, like all this whiteness around me, all we need is an instruction for those parts of the frame which says, don't change anything. Like JPEG, the MPEG standard breaks a video frame into 8 by 8 pixel macro blocks, and each macro block receives instructions on what to do with the pixels they already have. There are instructions for staying exactly the same, for moving, rotating, changing color, changing completely, and so on. Video frames with instructions like this are called P-frames, and they use about half as much data as an I-frame, which is pretty much just a JPEG. There are also B-frames, which are predictions or interpolations between I and P-frames. B-frames use a quarter as much data as an I-frame, so they really save a lot of space. This is all pretty easy to see on a video file that has been saved in an extremely low quality setting, like what you're seeing right now. Again, all these awful square thingies are called compression artifacts. Furthermore, sometimes a video file will be corrupted or missing some data. When that happens, you get an effect like this one. This particular effect is caused by a missing I-frame, which would have cleared away the old image to make room for a new one. Without the I-frame, the list of changes in the following B and P frames are applied to the wrong image. So now you know why a video sometimes looks weird or gets all blocky. Those artifacts are a result of the video compression being either too high or else some kind of error in the coding or transmission of the video data. Now listen, if none of that made any sense, everything I've said can be broken down to one thing: bitrate. The bitrate is the amount of data, or bits, that are being used every second. If a video has a low bitrate, it will be low resolution and/or low quality, with lots of compression artifacts. If a video has a high bitrate, it will be high quality and/or high resolution. So the more bits you have to work with, the better the video will look. There's just no getting around that, even with the best compression methods. Video compression is a balancing act between a good-looking video or a small file size. You can't have both.